Hello and welcome to the 58th video in this series for beginning programming in C. So this video is actually revisiting the linked lists topic, as you'll know by the title. Because the reason is somebody wrote to me, I can't remember if it was on a linked list video or the writing data video, but anyway, inquiring about how you go about writing a linked list to file and reading that list back in. Now, there are a number of ways of doing this, and the way I'm going to do this in this video is what I think is the simplest way to explain what is going on by it. But like a lot of the code that's being written with the linked list videos and also the writing data, everything is really done as inefficiently as possible so that we can sort of see, or you can see step by step how things are working. However, in preparation for this video, I'm just going to bring across the playlist here that I've got open for this playlist for all of the videos that I've done so far with this beginning C programming. You must have gone through already, otherwise it's not going to make much sense. Parts 53, 54, 55 and 56, because this is all of the linked list codes that I built up over 4 videos, which is in fact what I've got here as the chapter 58. You'll recognize if you've been through those videos, this code already here, where essentially we maintain a list of cars where we can print the list, add one to start, add a car or insert a car, and basically that inserts at any position in the list or anything like that. I won't go through the details of what this is doing because you'll already know, but I'm going to start this video from this code base, and I think that code base is from the linked lists insert item here. In fact, I'm just going to click on the video and pause that there and just open, whoops, not the Twitter, sorry, just open the link here to, yes, so it's this code here, which is exactly what I've just pasted in my chapter 58 here, which was available as the download, is where I'll be starting this video, because there's no point in going through all of the linked list stuff again. The other thing though that you should be aware of, obviously, is then I did a couple of videos, where are they? Here they are, writing data and reading data from a file. So I've got here the writing data to a file. I'll just go to the code here. So it's a very small code this, but the important part, as you understand here, is how we go about writing data structures to file. And then likewise, the next one in the playlist, I think, was the reading data from a file. And again, I just click on the code, and here we've got the read some data, and then we actually had reading data a specific index as well here in the code. So you need to make sure that you're familiar with this code and how it works, because we're going to be using, obviously because this is a video writing a linked list to a file, we're going to be writing data to a file and reading data. Okay then, I'm going to do this all inside one video because I don't want to split it into 2, so it will definitely go longer than the normal 10 minutes, hopefully less than half an hour. So first thing I want to do is just bring over the good old terminal. I'm just going to compile the chapter 58 that I've got here and run the program again, and if I remember correctly I just type add, and I can add a car with its speed. I'll type add again and add an Audi with 200, and let's just add a third car with, add, and I have to do enter, don't I, then the name, and 300, and I can print the list, and we have the list of cars here all linked, which if you watch the other videos should make some sense here. So if I just quit out of this, the clean should run, and it's freeing up the various pointers. Good, so I'll just clear that. So let's think about how then we actually want to write this information to a file. Well, the writing is much easier, you'll be glad to know, than the reading. So the first thing we're going to do is we're going to, above the main here, look at how we might write our writing function then. So I'm just going to do here void and write list to file, and obviously we need to take in our start pointer, so we actually have somewhere to start from, which is what we use then obviously to iterate through our list from the start pointer using the pointer that's in the racing car structure which points to the next. Again, I really have to make the assumption that you've been through the older videos so you understand the structure and everything here, otherwise we'll be here forever. Okay then, so writing the list to the file. There's a couple of things. There's one little problem with writing this list to the file, and the problem is this pointer, so to speak, here, pointer to another structure we're trying to write the file. The way we're going to do things in this is when we write this into the file, we're actually going to write this with these set as null. So we don't end up with any problems when writing sort of something that a pointer's pointing to into a static file. Obviously that's not really correct. We need to write the name and the speed. We're writing everything in the order that they are in the list, so that we know later when we come to read them, we're reading them back in the right order. So the only sort of trick we have to deal with in the writing is what we do with these pointers to maintain the integrity of our list. And it's actually not really difficult to do that. So first of all, let's set things up with our file, pointer to file, and then we want to open our file, so we use our good old fopen, and then I'm going to call the file mylist.bin, and we're going to use the W and the B. We're not going to do any appending here. We're going to assume that if the user has said we want to write our list, we're going to write a fresh list into this file and not append anything. So the first thing we need to do obviously is say if our pointer file is not equal to null. So if we've actually managed to open a file, else let's printf, printf and file open error, so that we actually know that we haven't even managed to open the file okay. Otherwise we've opened the file okay, so everything is looking quite good. So the first thing we'll do then is we're going to use some similar code as we've got in the various other parts of this project here. Plenty of duplication as we've built bits on, doesn't really matter, it's just for the demonstration here. So we'll have our current car, and we'll set that equal to the start, so the first car on the list. And now what we need is we want a hold next and a hold previous. So I'm going to take a racing car again, and I'm going to call it hold next and set that equal to null, and another racing car called hold previous. And all that is to do is to maintain the next and the previous of the current car that we're going to write, because we'll be setting these to null on that car when we actually want to write it. And what we can do now that we have declared those, the hold next and the hold previous, what we can do is go into our loop of actually writing the cars. So it's very similar to, there's a function somewhere in here that deals with printing the list. Here it is. The way this works, you'll remember, is it simply says whilst the current car is not null, then print the details of that car and set that car to the next car on the list. And we're going to do exactly the same principle here for looping through our structures to write them. So we'll say write whilst the current car is not equal to null, then we want to write this car to file. The first thing we'll do though is we'll take our hold next and we'll set that equal to the current car next, and I'm just trying to speed things up, and we want then the hold previous here is equal to the current car and the previous, like so. So that holds those in place, because now what we want to do is we want to set the current car next equal to null, and we want to also set the current car previous now, before we write this to file, equal to null, so we don't end up with any silly complications in there. And now what we need to do is we need to put our file pointer to the end of the current file. So the way we do that is we say fseek then, and we want to say our p file and 0 and seek end puts our pointer, whoops, should be an underscore, at the end of the file. And now we can do our write operation. So our fwrite, and then we're going to write our current car, and then we want to call a size of, and it's the size of our racing car structure. We're writing one of these, and the pointer we're using is our p file pointer, and that's it appended to what was currently already written in the file. That's this car written in. What we can do maybe is just say printf, and we'll just say writing, and we'll put the name and nothing more, just so that we know that things are written in there. So I can then say current car and name, like so. And now what we need to do is we need to set the next and previous of this current car back to what they originally were to be able to maintain the integrity of the list. So I want that to be the hold next and that to be the hold previous, and last but not least is hold next and hold previous can now be reset to null, ready for the next go around. So I'll set this one to null, set this one back to null, and then all we need to do now is say our current car is equal to our current car next. And that's what we actually need to do to write everything to file. Of course, we must not forget to close the file, like so. And we can also set this equal to null. And that's what we need to do then to write the list to the file. So I'm just going to, off screen here, bring the file directory up, so hopefully when it writes we can actually see that the data is in. If I just bring the directory over here, you can see at the moment I've got the chapter 58 here code I've been writing. There's some prep in here, I was just making sure all this worked earlier. So now I'm going to go into the terminal then and just hopefully compile this, and I haven't made too many typing areas already, as is my want. And now let's run in the chapter 58, and I'm going to actually quit straight out of that because it's just dawned on me that whilst we've written the write list to file, we haven't actually put a command in down the bottom in the main here to actually write to file. So let's take this else if here and just drop this in, and instead of calling it print we'll call it write. 1 2 3 4 5 is still correct, and we'll take our write list to file like so, and that should then write everything to file. So go back into the terminal, bring the terminal back over, recompile, and now run. And now let's add then some cars. So I want Ford and 100, and let's add again an Audi and 200, and let's add again and BMW and 300. Print the list, and now let's write the list. And now it says it's writing them all to file, so let's quit out of the program, and I'll just bring over the directory here, and you can see that I've got the mylist.bin here with 96 bytes in, where for now we'll assume that we've written the data in okay. So that's written our list then to file. So now we've got the slightly trickier step, which is now reading the cars in from file. So how do we go about doing this? Well, what we do is we use our fseek and our ftell to tell us how big our file is, and then what we do is we simply divide that up by the size of the racing car structure, which is similar to what you've seen in the reading data in instructional videos, and that tells us how many structures they are. And then all we need to do is loop through this number of structures and allocate some memory for a pointer, read into that pointer the allocated memory the appropriate structure from the file, and the only tricky bit of course in there is we've got to make sure that we get the ahead and the previous pointers set up correctly whilst we're doing this, otherwise we'll lose the integrity of our list. So above the main here then I'm going to start writing the read list in. Now the big thing to do here, you remember from the earlier videos in the list, is we need to maintain the integrity of our start pointer here. So we return the start pointer like so. So we have our read list in, and then we have our racing car start. And now some stuff that you're fairly familiar with. In fact, I can go up to the top here and just say, let's open our file. And of course, now that we're reading in, we want an R and a small b for binary. And we want to say, as usual, if and then p file is not equal to null, then we can do something. Otherwise, we have a problem. So I'll put error file open error, and I'll put just for read like so we know that we're reading there. And now what we have to do first of all then from this file is set start equal to null, and in fact what I'm also going to do is, you remember that we have this cleanup start right down the bottom here. When we read the list in fresh, we're actually going to completely clean up anything that we've already got in the program in our list. Now of course you may want to write some stuff that adds stuff to the list, which you can do, but the way I want to do this is just read in a fresh list to keep everything as short as possible for what's already a slightly long video. So the first thing we do is clean up and free anything that we've already got and set our start pointer to null. Now what we want to do is we want to start finding out how big our file is, so we'll do fseek then, and with a pfile 0 and seek underscore end. And now what we can use is we can say a long file size is equal to, and we use ftell of where the current pointer is, which tells us then how big the file is. Important now to call rewind to go back to the beginning of the file for when we start reading. And now we can say the num entries in the file, if you like, is equal then to our file size, which is a long, remember, which is why I'm casting to an int, divided by then, and we want the size of our racing car, which I think I've already written here, so I'm just going to copy that and paste that inside here. So that tells us the number of entries. So let's just print that to screen, so we can say num entries and a new line. So that tells us how many entries are in the file. And now what we want to do is we want to loop through each of those entries and read them into memory, which will allocate one by one. So I'll make a loop equals 0, and now we'll say for loop equals 0, loop is less than our num entries plus loop. And what we want to do then here now is we need to put the file pointer at the location of the current structure we're looking at. So to do this we use fseek to say where we want to go. The file pointer we're using is our pfile. The number of bytes we want to jump forwards then is our racing car size of multiplied by our loop. So if it was the first one, it would stay at the beginning of the file. If we're reading in the second structure, it will go to the end of the first structure and then read the bytes. And we need to use seek set here, so fseek knows what's going on. And now what you need to do is set our start pointer equal to something which will be our read next from the file. And just before I write that here, just so you can get set in your mind, we're essentially going to do exactly the same thing that we do when we call make new car. So you remember here when we've got like add to start or something, or whenever we're adding, we add to end here, we always call this make new car here and put it into the list. And this make new car, you remember here, declares a pointer pointing to some allocated memory. And this is then returned from the function. And we're going to do essentially the same thing now inside here, where we're going to also make a sort of version of make new car where we allocate the memory, except that memory will then be filled by a racing car's size's worth of bytes, beginning where the file pointer has just been set. So I'm going to call that function here then, we'll call this read next from file, and the argument's going to be our start pointer and our file pointer. Now obviously that's not going to work at the moment because I need to actually declare the function. So above this read list in here then, say racing car pointer read next from file, and then we have our racing car start and our file pointer to our pfile, like so. There's quite a lot of typing and code I realise in this video, but hopefully it's clear to you what's going on. Just to reiterate, all we're doing in this loop here is we're simply looping through each of the structures. We know how many structures there are, and we know how many bytes each structure is. So this is simply saying point each time we loop, go to the end of the previous structure, or the start of the structure we want to read, if you like. So before we call this function here, our pointer in the file is pointing at the start of the structure, which means now if we read in the number of bytes in one of these structures, we read that structure in. Okay, so what do we need then in here? There we need another racing car, as we always do, just to keep everything clean and readable. And I'm going to make something here called no, I'm not actually going to do this, sorry. It's always dangerous to do things on the fly, but never mind. So I want a size t turn value, and this is just a value that it's just the return value of when we actually read in. It returns this size t to tell us how many bytes we've read in. We won't actually need that, but we'll do it anyway, so the function's sort of complete when we call it. So we'll say then that if our start pointer is equal to null, so we don't have anything on the list yet, then we can allocate the memory for our start pointer. So we'll say that equals malloc, memory allocate, and then we want to allocate the memory of the size of one racing car, like so. And now what we say is our return value, and now we read in from the current place where our file pointer is set. So we're reading into the memory allocated for our start pointer. We're going to read in a racing car's worth of size of bytes, reading in one of these, and we're reading from where the current file pointer is pointing. And remember, that's set moving forwards one whole structure each time in the file. Of course, we've created the first one here, so we can already say that the next is equal to null, and we can also say that the previous is equal to null. Otherwise, things are a little bit more complicated because we need to find where we're adding this into the list. Now, we already do this, you remember up here. I'll just go up again where we add a car into the list. Let's find that. Add to end, here we are. We say if the start pointer is null, then just add to start. Otherwise, we need to actually go about finding where the last car is on the list and then setting the new car to be pointed to by that last car on the list. And if you've been through those videos, then that should make some sense, the code I'm about to type out now. So we need first of all our index car. So we'll make an index car, and that's equal to the car on the start of our list, which we know we've got because it wasn't equal to null. Let's just make a space there so that's easy to read. And now we need to allocate a new car. So we'll say racing car, and don't worry about the start there. And I'll call this new car. Is equal to the number of bytes allocated to it here. And now what we want to do is loop through to get the last car on our list. So we'll say while, and then index car next is not equal to null. And I've forgotten the X in there. So while the index car is not equal to null, then index car is equal to index car next, like so. So that now brings us then to index car will now be the last car on our list. So what we can do now then is actually read in to our new car the currently pointed to structure by our file pointer. And now we just need to add this car then onto the list. So we can say index car next equals the new car, and then we say the new car next is equal to null, and then obviously we say the new car and previous is equal to the index car, which maintains our list integrity. And last but not least, we just return our start pointer. So all being well, that should be all we need to do actually to read in. And like I said, this is working exactly the same way when we added a new car to the list. It's just, it's taking, rather than making a new car, we're creating the memory here, but then we're reading into that memory the structure that's pointed to by our file pointer. So there's a bit of code there, but hopefully it makes some sense. And I'm just going to go down now into the bottom here, and we'll make our read, which obviously is 4, and then the argument we have here is read list in, and do we take the start pointer? Yes we do, and we also have to do a start is equal to that. So holding my breath and bringing over the terminal, I'm just going to try and compile this again, and control reaches end of non-void function 265. What have I not done? I've not returned the start. So I'll just compile this again. Seems to have compiled. So the list we had before was then this Ford 100, Audi 200, BMW 300. So I'll just run this now again, and I'll type read, and you can see that we have read in 3 entries here according to this. If I just go to print now, and you can see we've got the Ford 100, Audi 200 and BMW 300 with the behind none and the ahead none. So at the start of the video, first half of the video, then we managed up here to write our list to a file, our linked list, and now you can see by rerunning the program and running the read here, we've then managed to read this linked list, doubly linked list in fact, back into the program from the file. So it was a bit of a long video, I apologise for that, but I hope it's helped and made some sense for you, and see you in the next one.